compute the double integral over the region R of x squared plus y squared quantity cubed dA, where A is the area element of the region R, and the region is the annulus between the circles x squared plus y squared equals 1, that's the unit circle, and x squared plus y squared equals 4, that's got a radius of 2. So we're integrating over the region between two circles. That's called a washer or an annulus. And we have the function here. It's obviously a very round shape here, and we have x squared plus y squared there. So we should be thinking about polar coordinates instead of using coordinates x and y. When we're dealing with round things, we might want to consider coordinates r and theta, because in this region, r goes between 1 and 2, and theta goes all the way around from 0 to 2 pi. Moreover, in polar coordinates, x is equal to r cosine theta, y is equal to r sine theta. X squared plus y squared is r squared. So x squared plus y squared in our integrand converts very nicely into polar coordinates. Now, the area element dA in rectangular coordinates, it's dy dx or dx dy. But in polar coordinates, it's r dr d theta. And the dr d theta could be switched, but the important thing is that you get this extra factor of r in the area element. So this integral, when you convert to polar coordinates, turns into double integral of r squared cubed times dA, which is r dr d theta. And r goes from 1 to 2, r is the inner integral, 1 to 2, and theta goes from 0 to 2 pi. Now the inner integral has no thetas in it, so that's basically a constant with respect to theta. And so that can be just moved out in front of the integral d theta, and the integral from 0 to 2 pi d theta is simply 2 pi. So this integral becomes 2 pi integral 1 to 2, and now simplifying the r's, r squared cubed is r to the 6th, times r makes r to the 7th dr. So we have a very elementary integral here in terms of the variable r. We get 2 pi times r to the 8th over 8 from 1 to 2. So we get pi over 4 times 2 to the 8th minus 1 to the 8th. And 2 to the 8th happens to be 256. So we get 255 pi over 4. Okay, let's try this again. In this problem, we're trying to integrate cosine of x squared plus y squared. So there's our x squared plus y squared again, which we see is r squared. And x squared plus y squared is less than or equal to 1. This is the closed unit disk. So we have the unit circle, and we're integrating over the interior. So r is going to go from 0 to 1, and theta is going to go from 0 to 2 pi again. So this integral will be the double integral of cosine of r squared times r dr d theta, r from 0 to 1, theta from 0 to 2 pi. And then the inner integral again has no thetas in it, so the integral d theta of 0 to 2 pi will just give us 2 pi. And now for the integral of r cosine of r squared dr, we need to do u substitution. So we're going to let u equal r squared. Du is 2r dr, so we'll just bring this 2 back in to make the 2r. So we have pi times the integral of cosine u du. Now, when r is 0, u is 0, and when r is 1, u is 1, because u is r squared. So we did have to change these values 0 and 1 from r values into u values, but with the transformation u equals r squared, they still stay 0 and 1. So we get pi times integral of cosine is sine u from 0 to 1, and that's sine 1 minus sine 0, and the sine of 0 is 0. So we just get pi times the sine of 1 as our answer. So polar coordinates, dA, which is dy dx in rectangular, is r dr d theta in polar. And x squared plus y squared is equal to r squared, and that's a consequence of x being r cosine theta and y being r sine theta, and of course the identity that says cosine squared theta plus sine squared theta is equal to 1.